Before Professor Kamkoti comes over, just a brief intro about him. He specializes in the area of computer architecture, information security and design. He heads the microprocessor development program and the information security education and awareness program at IIT Madras, funded by the Ministry of Electronics and Information Technology, Government of India. So ladies and gentlemen, let's give a round of applause and welcome on stage moderator Professor V. Kamkoti. We also have Professor Subhashish Chowdhury, IIT Bombay. Professor Subhashish, one of our panelists. Kindly come over, sir. And we have Shri Anil Sahasrabuddhe, AICT, joining us on the virtual mode. We have Raja Subramaniam of Synopsys. Mr. Raja, kindly come over, sir. We also have Mr. Sambit Sahu from Intel. Mr. Santosh Kumar from Texas Instruments. Mr. Venkatesh Prasad, RVVLSI. And also we have Mr. Jun Gu, the General Manager of Memory Business Unit, of course, Semiconductor Manufacturing Comp. Yes, Mr. Jun Gu will join us on the virtual mode. I think both of them have joined. Yes. Good afternoon to all of you. Let's give a round of applause, whoever present here. And also, we would like to welcome all the participants who have joined us on the virtual mode and even the panelists. Welcome to both of you, sirs. And it's now straight away over to Professor Kamkoti to take us through. Over to you, sir.
So very good afternoon. Last day after lunch session. We'll try to keep as exciting as possible. So that's the first challenge, number one. So I always, I want to link this session to, I want to start with an analogy. Suppose we are driving from Chennai to Pondicherry, right? First we see a board, a placard which says Pondicherry 163 kilometers. Then there is we need to have our car, a driver, and we need to drive safely. And there will be a mechanism if we have a puncture or something, there will be somebody to attend to it. Okay? So in my view, the government's role is that we have shown a path and we are setting up certain mechanisms to see that our travel is smooth. But then there's an industry which should own the car. And what this panel session is how we give you trained drivers who can drive the car properly. Right? So that's where we start. So we have a very exciting, a very broad spectrum of people. We have educationists. We have people from established industry. We have people who govern education. We have established business managers who have administered large-scale production industry. And we also people who have done at-scale training. Right? So that's the overall composition of this particular panel. And we would like to have discuss this threadbare, because unless we have a driver who drives a car properly, we can't reach the end goal. And this is a very, very important component of our semiconductor mission. So with this few words, let me just start with Sambit, who is the VP and GM of IoT and Edge Computing, Intel. Intel has been playing a very important role in this, in our overall development, especially from the DIR5, the Digital India RISC-V initiative. The first chip that came out, the RISC-V chip for India, Intel had fabbed it out at 22 nanometer. So I thank Intel on behalf of DIR5. Specifically, we are now trying to look at multiple aspects: the design, the front end and back end. Then we have the fab manufacturing, and then ATMP. And Intel has been doing this for several years, right from the 8080 to the current, multi-core server chipsets. And you have also jumped into what we call as the domain-specific architecture. And there is also a need for understanding these verticals from the domain perspective, right? So this is also something that comes out with the IoT. So as Dave mentioned in the fireside chat, there is a need for a different approach to design and manufacturing, specifically driven from the domain perspective. So, and that requires a different type of talent. So there cannot be a generic talent. There's a different type of talent for different domains. So now Samvit being the hem of affairs for that very important business of Intel, we would like to hear from him what are those type of talent and how do we bring that up? What is the expectation from a large industry like Intel in this direction?
Thank you. Good afternoon, everyone. And I lead the IoT engineering of Intel. We have 2,500 employees doing silicon platform software worldwide. And the engineering headquarters is in India. And when I landed in India through Intel India in 2005, the story was very different. We were struggling to get one SoC done, hardly a couple of IPs. I think in the last 15 years, not only Intel in India, but all other companies have really marched pretty well in delivering products and IPs. And now we have around, in the whole country, 30,000 semiconductor engineers delivering 3,000 chips a year. This is an amazing accomplishment so far. However, we are not done yet because the semiconductor demand is significantly high right now. We are growing from 500 billion to 1 trillion by 2030 in semiconductor revenue. And there are just huge set of applications you may have heard about. So we need to continue this journey ahead, whether it is Intel, the startups, the academics, the government, all of us need to join hands together. And there are three aspects that we need to focus on to carry this journey forward. The first aspect is building the technical skills or growing the technical skills at scale, because capacity is a strategy. So we need to continue to build the capacity. And how we can build the capacity, it has to be done grounds up. We have to introduce the right level of courses, the right type of courses in our colleges, universities, in our MS and PhD programs. So I'm looking forward to my colleagues and friends here in academics to do that. Of course, we'll be happy to help. Secondly, I think we have lots of good skills today, but we are lacking in some specialized skills, particularly in architecture. And as we are growing into new fields of AI, IoT, automotive, which Professor Kamakati was saying, we need those domain-specific architectures, because those architectures for the different segments could be very different. So we need to build these technical skills at scale. And third piece is the MNCs and the other industries have to play a catalyst role in building programs and building facilities in our institutions. I'm very proud to say that Intel India is doing a lot of things. In our Unnati program, we have plans for building 100 labs in different universities very shortly. And that will help the students very much. And secondly, we also have programs to train artificial intelligence for all citizens. And we have a goal of meeting 1 million citizens, training 1 million citizens. The second piece is culture. What I see that in India, our engineers are very smart, very energetic, very passionate, very committed. But what we need to do is how do we increase our influence? How do we define new things? How do we market ourselves in the global levels? Like in conferences or patents, we need to increase our presence there. So this culture needs to grow. Just by passion, hard work, commitment will take you to some level. To reach the levels of US, we need to really look at how do we increase our influence. And the other piece is strong collaboration is critical. The success of Silicon Valley was because of strong collaborations between universities like Stanford, Berkeley, companies like Intel and HP, and lots of startups. So lots of collaboration. We need to imbibe that in India and extend our collaboration. And third piece is innovation. We need to really innovate. The AI and 5G, these two technologies, as per market research, are going to enable a $17 trillion economy by 2035. So there are lots of opportunities to innovate. I was listening to Raja Kodri yesterday. He said, India should not be focusing on legacy stuff, but more focus on the new stuff, the upcoming stuff, like artificial intelligence, IoT, 5G, automotive. We need to innovate here. We need to innovate in these fields. And I really applaud the government's initiative and the DLI programs and PLI programs to encourage our startups. So innovation is key. So three things: technical skills at scale, strong culture of influence and marketing, and innovating in new fields. And all three is based on a foundation which our legendary ex-CEO of Intel, Andy Grove, said, that only the paranoid survive. We need to really be paranoid. Thank you.
Thank you very much, Samvit. I think like now we have AI course for every discipline, AI for chemical engineers, AI for naval technologists, right? So I think we should also have a hardware design course for every engineer, specifically mechanical, chemical. I think that's going to bridge this domain-specific part, because to teach hardware to a non-electronics engineer is much easier than teaching, say, chemical to electronics engineer. I think that's the thing I get. Now we go to Santosh, who is president and MD of TI. So acronym for TI, though it's called Texas Instrument, we also call it as Training Institute. Because so every time we meet a very senior person or who are non-TI, ask where did you start? They say TI. Right? So TI has been one. And very interestingly, I also found that people who left TI actually did something else. Again, came back to TI, reskilled themselves, and again, they were very happy to accommodate them back and even spawn out companies, and they have been doing this. And you had the first grand challenge of hundreds of engineers, or probably thousands of people participating in hardware design in the country. I think TI has launched, and it's been a continuous program. And from IIT Madras, IIT Bombay, everywhere, there have been a lot of collaborations with TI. So I request Santosh specifically to talk more about the statistics of manpower that we have, right? So today we were looking at making a holistic system, and you have been involved with mixed signal. I think every chip you touch is a mixed signal design. So how many engineers exist who can do an end-to-end chip and make it a product? And what is it that we need to bridge that gap? Thank you.
Thank you, sir. Thank you for the question. It's really hard to sit in front of professors and really speak, but I'll just do that because that's really the need here. The industry is like the audience that I see in front, right? Reasonably full, but can definitely have a little bit more people. But what is important to me in industry is just not really about how many people are there. It's really about the quality of the people, like the audience, right? I really care about who are sitting and what are they really going to ask us and take the message back. Similarly for industry, we are happy with much higher quality. Scale is important. I agree with Sampath, but I'm far more interested in having much higher quality. So to me, the need of the hour at this point of time, I think what we have done, industries particularly leading in the last 10 years or so, we came to India 37 years back. We were the first to come here 37 years back. The primary reason why we came and the reason why we continue to exist with the relevance it has got today is simply because of the talent. We have told it in several forums, right? That's really the reason why we exist. Today we deliver more than 50% of TI's products end-to-end right from here in our Bangalore office. I think what is important in the last 10, 15 years, maybe this is primarily because of the industry, the greed to have more people, the greed to go faster, etc. We are trying to make students coming out of the college employment ready, right? When I just look back, right, I would really like us to go back and tell the students, right, I'm telling my daughter who is doing engineering now, to be really more of product ready. To me, employment will always come. You can take a little bit more time. Go back and study linear algebra. That's far more important. Like what Professor said, right? If you are actually doing one branch of engineering, learn other branches of engineering. Be a true engineer, right? The holistic engineering is far more important in the long run rather than in your own domain you really try to do something, right? So my ask is very simple. When colleges teach, let them take more time rather than sending us ready to do what we have to do 6 months or 1 year later. We can wait. Industry has its maturity, we can wait. Let us just get them to learn linear algebra really well. Let's get them to do other branches of engineering before they really come to us so that we can truly make them product ready rather than employment ready. Only if the engineers coming in are product ready, we can take the country to market ready. Right? Because today we are making employment ready, which is really the need of the hour when students are studying. But when they really go through this, right, unless they can create and conceptualize products, right, we have very less number of people than several of our competitions here in the country. The reason why you are able to do complete end-to-end designs, right, from conceptualization to delivery of the products is because we do have that quality of talent that we have built over time. How have we done this? We have actually gone ahead and our hiring strategy is significantly towards hiring from the campuses, right? We hire from all kinds of campuses, more than 100 campuses today historically, and 80% of our hiring today comes from campuses directly. We respect all our competition, we respect people who are going and working outside, we would like them to come back, but that is when we really start a new domain. Mostly for our existing domains that we are actually growing, we are very, very happy to have people come from the campuses, challenge us, and they do challenge us on status quo, what we are actually trying to do, and make us definitely do better. To your simple questions, or what you really asked, how many people, I try to answer it by quality of the people, but I'll tell you that there are designs that we do, extremely interesting ones, very, very innovative in the market with a couple of dozen people, end-to-end, most of the stuff that we do, right from architecture, development, conceptualization, which market to work on, all that we love to do that kind of work here. Two, there are definitely longer programs which involve a couple of hundred engineers working for 2 to 3 years of time. Right? So it depends on the complexity of the parts that we are picking up and the market that we are trying to grow. It's varied number. We do have all kinds of work, but my two asks is really looking at it to make engineers coming from the campuses who are more and more prepared to be product ready and very good in other branches of engineering. While we look at semiconductor as an important industry, we simply cannot forget the fact that ESDM is so much more important, right? Because unless we do have great people who can design these boxes that our products are actually going in, and some of them coming back and working with the product definition, we are definitely not going to be as good as what we can actually be. So ESDM market, how are we really growing talent there? How can we really crisscross between semiconductor development and product development, which actually uses semiconductor chips, is very important. And absolutely with all the new work that's happening in India now, when we are also manufacturing ready and future-proofing ourselves with manufacturing, we will complete the spectrum, right? So ESDM is an important portion, manufacturing and all associated things that comes along with it. And go back and look at the semiconductor design where we have already established that clearly we are market leaders in it, right? Anything that can be done anywhere in the world, we can absolutely do that here. And several of you have played a very active role on this. But we must actually have much more active work on ESDM. We've made some progresses, but we can do a lot more there. And of course, with manufacturing, we are looking at it to see how we can complete the spectrum.
Thank you very much, Santosh. And I surely, we take these points, and of course, we'll discuss a bit after we finish one round. Now I go to Raja. He's been with Synopsys. Synopsys has been a great supporter of many initiatives of our country. We have started the Special Manpower Development Program in VLSI 20 years before. And from that time, Synopsys has been our great supporter. I still remember writing purchase orders in those days in 2001, 2002. Thank you, Raja, for that. Please give a round of applause to Raja for... So, Raja, now, in this marriage of semiconductor, the bridegroom and bride is the tools, right? So, now, please do. What is it that you feel that you can do in terms of building the talent with your tools? What sort of offerings is there going to be now that we have the semicon policy for India? How are we going to, what do you think would be a great approach for our country?
Thank you. Thank you, Professor. So, good afternoon. Whether it's x86 architecture or ARM architecture or RISC-V, the underlying layer of all of this is the EDA technology. So EDA technology helps all of this, and thankfully we've been, I myself personally have been in the EDA industry for almost 3 decades and conceived part of the committee member of the SMDP, even before METI was born. It was the Department of Electronics with a few key resource centers, they were called then. The top 5 IITs were part of it, and we divided the country into north, south, east, west, and picked 4 colleges of repute across India. And today, all the semiconductor companies, both global companies as well as our own companies, as well as the local companies, have really worked out of that initial vision that was painted by Department of Electronics those days. Going forward, in terms of what we are doing in the last 20 years, and most recently, just about an hour back, right, we signed an MOU with METI to now expand this to more than 120 colleges. So within the next few months, and all of this will be put on cloud. So we'll have access to all of the EDA technology available to every nook and corner of this country, which our budding grad students can definitely leverage from and come that much more better qualified into the industry. Is this enough? Obviously not yet, because you heard the rest of the panelists talk about scale. So I'm sure for a country today, we're not just looking at India, because we ourselves, Synopsys has about 89 offices throughout the world, and thankfully I've been in the company for more than 25 years, and I get an opportunity to travel to various offices of Synopsys, and to every office, whether it's in Europe, whether it's in Far East, or in the US, right? I walk in, I see an Indian employee who grow from one of our colleges here, got associated with a VLSI company, maybe TI, like Professor likes to call it, as a training institute, and then has successfully, at some point in time, either become a customer of ours or is working in the EDA technology. So it gives us, great, look back to see that we are now contributing talent to the whole world, not just India. Of course, now that with the push that, with Semicon 2020, right, we see a lot of buzz happening. And so we definitely think we are, as an EDA vendor, as an IP provider, we have the skill to provide this technology at scale so that more and more students and research institutes in India can leverage this and get to look at the next level of innovation, solving the more complex problems that all of us as humanity face. Thank you.
Thank you very much, Raja. And again, I place on record your great contribution personally and from your company to our India semiconductor program. Now, we just move on to manufacturing. We've been talking more about this product and the tools. We have Mr. June, who is the General Manager, Memory Business Unit of the Power Semiconductor Corporation of Taiwan. So we request Ms. June, welcome to this conference, and very nice, and thank you for joining. We would like to understand from a manufacturing perspective, what sort of manpower requirement that you have, what sort of courses you think that the students should have as a fundamental understanding of manufacturing so that they are almost ready to take up a manufacturing job, and what are the challenges you are facing specifically in recruiting such talent. Mr. June? You are muted, so hello. You are muted. We are not able to hear you.
Sir, you're muted. Kindly, yes, unmute yourself. Or can you raise the volume or something like that? Nothing is coming. Yeah, I think he is now putting on the headphone or something. Yeah, there's some connectivity problem at their end, sir. Yes. Yeah. Yeah. No. We can't hear you.
We can't hear you. Is it? I think, can you reboot and start? I think that solves the problem mostly. Right? And,
that's again Indian technology, sir.
Right. And right.
All engineering colleges, we learn that.
Hello. Yeah, we will just, we request you to reboot the system and join the link. Thank you. Yeah. So while we'll wait for Mr. John, now I request Subhashish that we have now that we have listened from all these people on the requirement of talent, now as IITs, what we can do, and please give your vision on how we are going to satisfy the talent requirement of our country, given our semicon mission.
Okay, thanks, Kama. You know, we heard here people who have developed tools. We have like architecture. You know, we have the, you know, those who are making chipsets. And maybe we should have somebody who is also assembling and making a final product. So where does, you know, I would say people like us, IITs, NITs, other so many, you know, 1.2 million, I think, graduates. I think Professor Sahasrabudhe is here. He can tell where do we actually fit into this ecosystem. Now, you know, right now with this semiconductor focus that we are putting in here, you know, thanks to this great initiative by the government, the question is that what is lacking right now is the talent pool, and at what level? See, if you go back, you know, maybe I would say around 90, early 90, and see that that time all the computerization was happening, okay? And there was a need for large-scale training. And what happened was that, you know, there was a mushrooming of so many training institutes you could see across the road, and they could, to some extent, take care of the fact, because that needed a kind of training, which those kind of institutes are good enough. Now we are talking about training people in certain areas which are very high-end, you know, high technology areas. And normally, the lifetime of a high technology area is also very short-spanned. So there is a, you know, it keeps on, you know, you have to keep on updating yourself with the new things. You need to have a lot more depth, not only in physics, engineering, everything that you need to do. And also, what you possibly, you know, I can take it, another example is that probably, you know, machine learning, artificial intelligence. This also needs a lot of manpower, which is not possible by those kind of people who are on the, you know, did a great job those days, but no longer does. Here, actually, these educational institutes have to come together. Now, what is the first thing, right? See, right now, we probably produce manpower, which you can count in, you know, few hundreds, right? But you need like thousands, right, okay? So we need a proper handholding, because such kind of things, when you go for high-ending, the tools, devices, everything is a lot more expensive, okay? Sometimes you cannot even have touch them, right? Even those kind of things you have to do on the simulations, right? And we actually, that's where we need to have proper handholding. No institution here, I would say, you know, whether it's IIT or something beyond that, can afford to do that kind of training unless we sit down with all the industry people together. First thing is that we need to define the curriculum. What is very appropriate? And this curriculum also, We have to keep on updating every 3-4 years or something. It's not like once it is written on the stone and you keep on doing year after year. So that will not work. So that means even, I think, if you go beyond the research institutions where the faculty has to be retrained, that's a big exercise that we need to do, right? Then what happens is that normally education, typically, is normally you have input, there is a process which is an education where you may have the pipeline of the students in, where you have curriculum, delivery, all these mechanisms, and then there is an output at the end. Now, what is the output? As of now, the output of an educational system is delinked from the process, because we train the student the way we think we should be training them, okay, or the student think they should need to be trained, but not what I think the industry requires. That's why I said there is a void, because you may have a degree, you graduate, but you may not be employable. That kind of issues are happening. And as it goes today, the interdisciplinary and the domain of knowledge that you require is a lot more than by considering purely, let's say, E or CAs or mechanical. It has everything. If you look at the heat dissipation, you have to look at the completely the mechanical engineering aspects of everything, right? So we need these people not just from E and others, but it has to be from somebody which is a courses taken from all these disciplines. Professors and others, they can come together. But what is also required that many of these colleges, and including even many of the IITs, we may not be able to provide them the actual hands-on training. So we have to have a very strong entrepreneurship. I think the TI does a lot of things as use training, but these are the people that you have to place them, maybe certain amount of time that they can spend, which of course helps them to upfront what they call it pre-placement and others, which can be given to the beneficial to the students. But there has to be certain, kind of immersion of our students. Now, coming to the other one, who delivers? The professors, Now, if you tell me certain areas, as being the director of IIT, and I was the E head, we were desperate to get people in architecture. And where are the people? Or maybe in the VLSI design. If there are few, the industry will pay a lot more and get them. We'll never get them, right? Kama is an exception, okay? So if you have this kind of thing, then we need people from the industry to come and teach those courses. We have no problem. Somebody, being shared by industry and an academia. It has to be done to this thing. And this, because of the pandemic, now we have opened up all these online and other facilities. We should absolutely use that whenever it's required, right? But unless we do it together, okay, so there are a lot of experts, and they are really excellent experts, okay, in the industry. We need them here. Similarly, we will be very happy to have some of our faculty members, if they can spend time, their sabbatical, whatever it needs, okay, they can go there. So unless we do that, we'll never see the end, the light at the end of the tunnel, because we have to, what I understand, that we have to produce something like almost 85,000 engineers in this area. Where are the numbers, right? Each IIT may be producing in that particular discipline maybe 15 or 20 per year. So it will not happen. So we also need another aspect is that, the lateral movement of people who are already in certain profession, okay, and bring them on board to this one through some kind of a lifelong learning process, continuing or evening programs that we can actually do. We can work with some of this industry and do it from the industry personnel so that they can now change the job. Because see what happened, the job profile changes. Many of them would like to go into this, okay? And there are more opportunities in this. So I think we should also allow that. And then I think, the vision that we have, the Prime Minister and all these things, that the whole purpose, I think it's a collective responsibility to make sure that this happens. Thank you.
I think as directors, we have actually enabled a lot of interdisciplinary programs in all the IITs. Specifically, we started with one thing. We go to the first year class of non-computer science and ask them, what is your worry or sad? Sir, we didn't get computer science. So, so that is where we said, okay, you have a core discipline, but over the next 2 years, will find a lot of things which are much interesting than computer science. Now, all the IIT's curriculum, we have now made it so open that there'll be one core area, but you can explore multiple areas, and that is going to fit very well into this semicon training also. So with this, I now go to Mr. Jun, who has joined us back. Thank you. We would like to understand the talent pool necessary for manufacturing purposes. Thank you very much.
Yeah, good afternoon. Can you hear me now?
Absolutely.
Oh, great, great. Yeah, sorry, I had to switch to Chrome browser to get the audio problem fixed. My name is Jun Ku. I'm actually a business unit general manager for power chip semiconductor manufacturing in Taiwan. Actually, we're probably third largest foundry based in Taiwan. Worldwide is about, I think, is seventh in terms of revenue. So actually, I think with myself actually is actually not exactly in manufacturing, and I'm more on the business side. Actually, I started my career with Intel as a processor designer. I only actually joined Power Chip 2 years ago. Before that, I was mostly doing product side of things. So manufacturing is also a new thing to me as well. But unfortunately, our president has another engagement. He's not able to attend. He's probably better qualified to talk about the manufacturing. But I do, I mean, within last 2 years, with the expansion capacity everywhere, we do see a large demand on the manufacturing talent, especially in Taiwan. Actually, Taiwan, relatively to India, is a much smaller country, is about 24 million people population-wise. So the talent needed for, but actually Taiwan manufacturing wafer capacity is #1 in the world, over 20%. So as you can imagine, I mean, for manufacturing, you do actually need bodies, not just a few key smart person, right? So it is a big issue in Taiwan. So from what I can see, there are two issues. One is the R&D talent. So those are usually university or maybe even master's degree or PhD are required. So for that, that counts probably maybe 10 to 20% of the people you need in industry. Then there's other large portion is the skilled technician, right? You need people running the clean room, maintain the equipment, things like that. Those actually is also a big issue because you do need a body for that. The fab is running 24/7. You need a lot of people to do the job, right? So for the R&D part of things, actually our CEO and also the founder of the company, last year he actually seeing this talent shortage, he actually proposed to Taiwan government to establish dedicated semiconductor colleges in the top tier universities in Taiwan to particularly attract students from various backgrounds into semiconductor training. So for now, Taiwan actually established 5 semiconductor colleges in the top 5 universities. And these colleges actually, they raise fund from industry, then the government matches the fund. and the colleges is postgraduate. So they recruit undergraduates from various disciplines, then get into master's program and a PhD program. So the plan is to recruit about 200 students each year from each colleges. Then there's about 1,000 engineers. But this obviously is still not very sufficient. Right now in Taiwan, as I said, we account for more than 20% of the global capacity. We have about maybe 200 or 300 people in the industry, right? Not all of them are in manufacturing. As you probably know, Taiwan also have a few pretty big fabless design houses. They also require a lot of engineering talent. For manufacturing, even maybe just 200,000 people, if you have about 10% or maybe 5% change every year, so you need still a lot of new, fresh talent into the field. So for this, I think for a small country like Taiwan, we actually are adjusting our policies, and the universities are actively recruiting foreign students to join into this industry. I think for this front, Taiwan and India actually can collaborate a great deal. As the panelists already discussed, for design and the software, India actually had a long history working with global companies, especially US companies. So there are a lot of talent base already. But for semiconductor manufacturing, a lot of things you really have to have hands-on experience, not just classroom courses or remote learning, right? So Taiwan actually, Taiwan fabs and can probably provide this training ground for the India as a kind of as a practicing or training ground for India hardware manufacturing engineering talents. So I think actually our CEO is also promoting this as well, and I think we have worked closely with India Institute of Taiwan, which is more like a India embassy in Taiwan to try to establish this kind of program. Actually, I think India I mean, with large population and a very well undergraduate education, such as IIT, I think it does can serve as a talent pool or hub for the global semiconductor industry. Yeah.
Thank you very much. And yes, we would have a lot of things in common. And certainly there are some models that already we had worked out with Taiwan. And I think the chairman AICT is here, and he will mention during his remarks. Thank you very much. And yes, we look forward to have many more such interactions and learn the best from each other. With this, I just go to addressing scale. I'll request Venkatesh, who is the Group CEO of RV Skills, trained more than several lakhs of people so far in this semiconductor domain. And like to request your remarks specifically addressing the scale point of view.
Good afternoon, everybody, and I thank the organizers for having me on the panel here. I represent a brand, RV, which has a 75-year of legacy in traditional education and about 20 years specifically in skilling. in the year 2002, the president of the Rashtriya Shikshana Samiti Trust, Dr. Panduranga Shetty, felt the need to enhance the employability and offer skills to the students. And I was the founder CEO setting up RV VLSI at that time, which has now become RV Skills. Now, in the last 17 years, we have trained around 10,000 engineers, and we have close to 100% placement in the VLSI industry. We have placed people in product companies, in service companies, in EDA companies, in IP and foundries. So we have some experience that I would like to share with the audience today about how we can scale and achieve the goal, a very ambitious goal of skilling 1 lakh engineers over the next 5 years. The first and foremost thing that over the last 17 years that I have seen is there is lack of awareness about VLSI. And within my extended family, I'm finding it difficult to convince people that after you finish your engineering, you have to get into the VLSI industry. There's a lot of scope. So I congratulate the government for setting up Semicon. I think all these days, the awareness was being created by the industry bodies. For the first time, the government is doing this. Government has a bigger machinery, and I think the message will go out far and wide. So I really think that this will bring in a lot of awareness, create a lot of awareness amongst the people. Now, when you do that, the next problem that we're facing is the lack of talent. Even the IITs are not immune to this problem. We have very well qualified engineers who are either going to the fintech industries or to other industries, which with the awareness and creating a roadmap, I think we can plug the talent pool. There will solve some portion of the problem. The third, and I think we have Sahasrabuddheji here on the panel too, is with NEP coming out, there is so much that we can utilize it for the betterment and improving the employability of the students out there. There are provisions currently for doing mini projects. There are provisions for internships. There are provisions for doing a final year project. I think we should not let this opportunity go waste. We should, as a body, sit together, discuss, and formulate a strategy. I think Subhashis was talking about content and how we can develop content. There's a lot of experience on putting out contrived test cases where we can enhance the productivity of engineers who come out from the colleges. Another piece which will help us in scaling is adopting technology. We just heard from Raja talking about going to the cloud. I think that is the way to go. The biggest issues that we have found with most colleges is installing the software and getting it to invoke a license and check out a license. So this will greatly improve that, and going cloud, using the technology and using LMSs in order to take forward is the right way to do. Now, one thing is, when I started this institute, I was 35 years, and now I am 54. So I'm aging every year. But the age of the student coming to the institute is still around 25, 26. Over the years, what we have seen is the attention span of the student is falling. Now I cannot hold his attention for more than 7 or 8 minutes. So when we take up education through a blended online mode, I think we should be mindful of the pedagogy of teaching that we are going to adopt. So we have to adopt concepts of micro-learning, and we have to make sure that it's interactive, it is engaging, so that the learning outcomes are there, completion rates are high. Otherwise, we are going to continue to see a very low completion rates on online courses. That's about it, which I wanted to say. Thank you very much.
Thank you very much. Now, we go to Professor Anil Sahasrabudhe, the chairman of AICTE. Sir, so we have a challenge, we have a need, we have some basic building blocks, we have industry and international partners who are willing to support. So, sir, it is all in your hands. How do we put all these things together? Because you are now the boss of the scaling. And so, all yours. Looking forward to hearing from you.
Yeah, thank you, Professor Kamakoti. In fact, I listened to all the industry people, IIT and RV College. So what it comes out to be is semiconductor mission has to be certainly multidisciplinary. We require not only people from electronics and VLSI background, but we require people from chemical engineering, mechanical engineering, and all other disciplines of engineering to put together. And therefore, and also, as June was saying, we require fabrication, manufacturing requires another set of people, be it in terms of equipment handling, be it clean room handling, be it running the fab itself in terms of quality product delivery. And when the fab is running continuously 24/7, ensuring water supply, electricity supply. So it is absolutely multidisciplinary in nature. And therefore, we cannot have any other thing than solving a jigsaw puzzle. We have polytechnics and ITIs required for lower end manpower requirements to run the fab, to run the machinery, to take care of the technician job. On the other side, there may be some supervisory people at the diploma level, and then engineers who are graduating engineering for taking care of some of the little higher end work, and people from IIT and universities who come from research background to have the further new designs to be created. And I am sitting here today from Hubli. I'm in Karnataka only, from another institution in Hubli, which started a very small unit of what is known as Sankalp Semiconductors. This was about 7-8 years ago, with 6 people on the campus, and today it is more than 600, giving a lot of designs to US companies. So I think there is a lot of talent. We should not think that there is no talent in this country. In a small place like this, if there is talent, I think talent exists all over. What we need to do is, we need to do a finishing touch to that. We need to hone their skills further. And more importantly, rather than theoretical knowledge, how do we bring them actual practice, hands-on? And that is where students will not get bored. You were telling, Venkatesh, that they have an attention span of 7 to 8 minutes in a classroom where there is one-way delivery of lecture. If you involve them in interactive discussions, the attention span is more than 30 minutes. And if you ask them to do something in the laboratory, work on the, on the field, you have to develop some tools yourself. I think their attention span is pretty long. And this is our experience in terms of Smart India hackathons, which we have been conducting in the last 4 years. Challenging problem statements given to them, they give solutions, and 36 hours without sleeping they work. I think on one hand in the classroom, their attention is 8 minutes. On the other side, they can work non-stop 36 hours. So it is actually, how do we use that talent? How do we hone that talent? And that is where the role of educational institutions, first in terms of the curriculum being up to date, using industry standards, calling industry people for even taking some of the classes, sending students and faculty to the industry for internships, and so that they're abreast with what is happening in the field day in and day out. The technologies are rapidly changing, and there must be constant lifelong learning philosophy adopted by teachers first, and then in turn to the students. I'm sure with this as the mission, which the Honorable Prime Minister is talking about, Atmanirbhar Bharat, with huge budgetary provision which has been also made, I'm sure we will all put together our efforts in order to make this successful. I think I would like to give simple statistics. In the AICT approved total 3,200 engineering colleges and about 2,800 polytechnics who give diplomas. In 458 colleges, there are 8,543 seats available at MTech level in this field. Maybe not directly, only directly or indirectly, embedded system design, VLSI, nanotechnology, or combination all of this in electronics department, postgraduate seats. In terms of undergraduate and polytechnic, this year we have opened up 2 courses, BTech in electronics engineering with VLSI design and technology, as well as I think these are 2 important. What they start taking up these courses, I'm sure some training will be required, and I'm happy. June has already said that Taiwan is open for giving internship opportunities for our students. We have been working with them. We are working with US universities in terms of 2+2 joint bachelor's program in engineering, 1+1 master's program in engineering, research collaborations in terms of internship opportunities, joint offering of the courses. I think sky is the limit. We put in all our efforts to make it that this semiconductor mission of the Government of India, where it has been very serious about it, make it successful. Thank you very much.
So thank you very much. So we end this panel on a very, very positive note that we have all the building blocks. We have a path by which we can scale. We have the support from the government through the semicon policy, and that we have a great demand for, from an employability point of view and from the customer's point of view. And we also have great support from all the international partners. With this, there's nothing that's going to stop, and in the years to come, we are going from height to height. With this, I thank the organizers for giving us this opportunity to come together and talk about this most important driver for the semicon policy, the human capacity, without which it's not going to be possible to run such a large program. Thank you very much.
Ladies and gentlemen, the moderator for this all-important session, the panel discussion on global partnerships for the future of technology. I would also like to call upon Mr. Barry O'Farrell, Australian High Commissioner to India. Hearty welcome to you, sir. Also, I would like to call upon Noor Gillon to kindly come over, sir, the Ambassador of Israel. Drew Shifleton, Consulate General of U.S. Embassy. Also, we have Gert Heiskoop, the Consulate General of Netherlands. Dong Kyu Kim, the Director General of Korea. Yes, ladies and gentlemen, it's one of the most illustrious panel you would have attended several conferences, but this, I think, is a real, let's give a huge round of applause for this highly illustrious panel. I mean, the first of its kind in the country, which is happening in Semicon India, the first ever edition of Semicon India. I would now hand over the session to Professor Raja Mohan to take us through.
Thank you for that introduction. We have an exciting panel, as the MC said. So, ladies and gentlemen, let me welcome you for this very special panel in this Semiconductor Summit. Unlike most other sessions, this one is going to be focused on global partnerships for this mission. We all know the semiconductor mission of the Government of India is one of the most ambitious and one of the most challenging missions ever undertaken by India since independence. There were a number of other missions before. I mean, you can go back to Homi Bhabha and the start of India's nuclear energy program that spawned the space program, that also spawned the India's electronics program. And then we've had a whole range of missions since then. But this one, seeking to make India a semiconductor hub, involves a far greater energies, far greater scale. It needs to bring together India's technology, science, industrial capabilities, and bring them in partnership with the global partners. So this makes it even foreign policy and diplomacy are going to be very much part of it. But in the end, this is really about building national capabilities in partnership with other countries for mutual benefit. And we're undertaking this mission at a time of very complex international environment, which has fundamentally altered the context of the semiconductor manufacturing. Till 3 years ago, the general belief was that efficiency is what mattered. Borders did not matter. Politics did not matter. You took production to where it was most efficient to produce, and things moved from one part to another part. So China, being the factory of the world, did not make a difference to the world, because it didn't matter where it was being produced, as long as it was being produced efficiently. Taiwan produces most of the world's chips. That didn't seem to matter. But today, 3 years down the road, since that general assumption, what we have today is politics matters as much as economic efficiency. Because there are major conflicts between US and China. There is also the India-China conflict. There is now the Russia versus West conflict. So these conflicts have created a fundamentally different situation in which technological cooperation must take place. We've already seen significant changes in the international environment. and that the dangers of relying just on one source for production of anything, that is a problem. Therefore, today the world is looking at new ways of doing things. And within that, the semiconductors question is far more complicated because no other sector has had so much geographic concentration. Just you had Taiwan and South Korea, my friend is here, that most of the production has taken place. China is trying to catch up with them. And then the industry concentration too is really just down to 3 companies now. So this is really a completely challenging situation. And we are trying in this situation. The principle now is everyone believes large countries must have some national capabilities in this. But at the same time, the scale and the difficulty involved in making semiconductors is so complicated, it can only be done in international collaboration. So partnerships and collaborations become a key element. And the partnerships, unlike in the past, are going to be between like-minded nations. Nations which trust each other, which can bet on critical elements of this vital supply chain, because semiconductors are everywhere, that we need to have enough trust and political confidence in each other. So that is the context in which the semiconductor mission is operating. And within that, today on this panel, I can tell you that we have 5 of the most like-minded partners on this stage. We have, if you go from the other end, we have Israel, ambassador from Israel. Israel, is one of the world's most leading technological centers of innovation. So there you are. I think they're into this business very well. And then we have the Dutch consul here, who, Netherlands is the only country that makes the machines which make the chips. A lot of people make chips, but only Netherlands makes the most advanced machinery, the extreme ultraviolet mechanics of making chips. We have Mr. Kim, who is from the Korea, which makes a lot of chips, but Koreans, as you know, are the second largest producer of chips. So you're here. We have Australian High Commissioner, Barry, who's Australia, is probably today leading the whole technological coalition building in relation to India and its partners. They're key members of the Quad. They run this whole lot of programs which try to bring partners together. And here they too will have a major role. And finally, Drew from the US Embassy in Delhi, who looks after the economic, is the Minister of Economics. The US, of course, has fundamentally altered the template in which the semiconductor mission is going to take place. The last 3 years have seen dramatic changes in the way the US looks at China and the US determination to decouple at least critical sectors from China and set the stage for a new framework for cooperation. So this is the 4 panelists that we have. So I'll go from the left. What we'll do is, what I've asked each of the panelists to speak for about 6 minutes, essentially addressing 3 broad issues. 1, where is the country in relation to technological development of semiconductors? 2, their international strategy for collaboration. And where does India fit into that partnership model that they have? So Ambassador Naur, we'll start with you. The floor is yours.
Thank you very much. Thank you, Raja, for speaking of Israel as being a technological hub. Many refer to Israel as the startup nation because of the huge numbers of startups per capita, the highest in the world. Investments in startups, highest in the world per capita, and total number of startups over 7,000 for a country of 9 million people. So also in the semiconductor field, Israel is very active. The biggest player in Israel is Intel. Intel has in Israel for quite many years a fab, but also as important or more important, an R&D center for semiconductors. And another player, we have actually 3 main players. The second important player is Tower, which is one of the world leaders when it comes to analog semiconductors. Tower, an Israeli company, has 8 factories around the world, 2 of them in Israel, and R&D in Israel. And the third player, there are many smaller companies, startups and others, who are producing elements of the semiconductor. So technology which is connected to semiconductor. And now the two first players are probably going to get married soon, in the sense that Intel announced that it's going to procure a tower during this year, so the process has started, not concluded yet. What the good news, I'm coming directly to the good news and the practical news. The good news is that this morning I had the pleasure and the honor to be with the Chief Minister when we witnessed the signing of an MOU between Karnataka and Tower for building here a fab. Tower, by the way, has with the space agency already made the first fab. It's not a commercial one, it's a research one, but it's still working here, the only fab that is working. So hopefully, if the whole process will continue as we hope, in the coming year, I think the breaking of the ground and the beginning of the works here, this will be a very important fab in the sense that it will create here also the ecosystem. So directly in such a factory, the investment is around $3 billion for analog. Directly, it should employ around 1,500 people, but indirectly many, many more. But more important, it will create here, I think, an ecosystem around the semiconductor. Also, we spoke this morning together with the Chief Minister and the Minister for Technology during the signing that the IIT here and other institutions will have to start preparing the graduates for practical. That was the request of the Chief Minister, to prepare the graduates with practical preparations to work in the field of semiconductor. So I think, I hope it will happen. It will be a big thing, especially for us, India and Israel, because we are celebrating now 30 years of diplomatic relations, and this will be a huge celebration for us if we can do that. So we are happy. We are happy for Karnataka, we are happy for India, and we are very happy for Israel. So thank you.
Thank you, Nord, giving us the Israeli perspective. Gert, tell us about what the Dutch think.
Does this work? Can you hear me in the back? Yes, wonderful. Namaskara. Good afternoon, everybody. A pleasure to be here and to give you some perspective from Northwestern Europe. Electronics, semiconductors is big business these days. When I joined the Foreign Service 40 years ago, I'm as old as the integrated circuit. We were both born in 1958. When I joined the Foreign Service 40 years ago, it was a different world. I mean, an incubator was something you only found in a hospital. An accelerator was something you found in a car. And a conductor was a person who was standing in front of an orchestra. So a semiconductor was the same guy with a maximum height of maybe 4 feet. But all that changed. Nowadays, these things have a different meaning. Our claim to fame in the Netherlands when it comes to semiconductors is that we are not so much a huge producer of chips, ICs, and semiconductors, although we produce these things. We make the machines that produce chips and semiconductors. The company that is involved most of that in this business is ASML. I have a strong personal link with that company as well because one of my sons works in ASML. And they have now something like 80% of the market. It's on the Dutch stock market is the biggest company by far. Their stock market value is as big as Shell and Philips combined. And these are not small companies either. And the future for this sector is very bright. There's a lot of collaboration already with India in this field because in the Netherlands, the biggest Indian community in the European Union lives in the Netherlands, 30,000 people. And most of these people work in technology. A lot of them in the south where ASML is located. You see, when you compare India and the Netherlands, we have the capital, Delhi for India, Amsterdam for the Netherlands, where everybody always travels to. There's a finance center, Delhi, Mumbai here, and Amsterdam also in the Netherlands. And there is the Science and Technology Center. That is, of course, Bangalore here in India. And it is Eindhoven Brainport in the south, and that is where so many people work. We employ thousands of scientists and engineers, and many of them from India. You see, Dutch universities train a lot of Indian students. There are now over 3,000 Indian students studying in the Netherlands, most of them in fields like engineering and science. And we try to keep these guys because they're bright and smart, and they often work for ASML. Yes, you can applaud your countrymen living in. We're very grateful to have them because we need them for our high-tech economy. And we're looking for methods to improve and increase the cooperation between our two countries. You couldn't possibly have missed the visit of Indian President Ram Kovind to the Netherlands a few weeks ago. It was all over the press. The Dutch Foreign Minister was here last week. And we are looking at ways to increase the cooperation between our two countries, also in the field of semiconductors, because, as you all know, there is a problem with semiconductors these days. There's not enough of them. It's hampering the production of cars, household electronics, phones, TVs, you name it. These things are in every item we need. So production needs to be extended to other places, and it has to go up. Right now, it's concentrated in East Asia, in Taiwan, Korea. My neighbor will talk about it later on, Japan and China. It's not a good idea to increase production in a country like China for many reasons, also for strategic reasons. So it would be good if we increase production in a like-minded country like India, and that is one of the things we're aiming to see. And that is basically what we're working on. It's one of the part of my job here, and I see that the moderator is looking at me, so I'm overextending my time. So this is where I stop. I'll take questions later on. I'll pass the mic to my neighbor on the right, Mr. Kim. Thank you very much.
Thank you, Gert. It's really I think one of the points that are being discussed in this summit is the Indian talent and its global impact. I mean, I think that's what you mentioned. Thank you for that. And Kim from the.
Thank you, Mr. Moore. Thank you so much, to invite me here in the Bengaluru for the India future business industry. I think it is a very significant event for the future of India, and I'm very happy to have you here because I live in here. So especially I would like to thank you, Honorable Minister Sri Rajiv Chandrasekhar, to host this significant event here in Bengaluru. Appreciate. I can say that Tuna Pada Kalu. Is it right? Thank you. Say the Korean companies who have established their facility in India have tremendous contribute the concept of making India policy for the last 30 years, since the 1990s. As everyone here, industry leaders know that starting from LG Electronics, Samsung Electronics, and Hyundai Motors, Kia, POSCO, most of the Korean manufacturers, major manufacturer conglomerate, have their presence in India to hire several 100,000 employees to produce the best quality of product for the client in here and domestic or overseas. That's the concept of making India, we believe. It's not just for the Korean company itself. It is for the India and for the global, the concept of making India. I want to point out the Hyundai Chennai factory have produced 700,000 cars in a year. Among them, 150,000 cars are exporting to other countries, Middle East and South Asia, which is exactly the model of making India, the asset of India's industry. So this is the concept that Korean companies wanted to build up relationship in India. Now here in Bengaluru, I want to say Samsung and LG, they have the biggest overseas research center here in Bengaluru, hiring around 4,000 high qualified IT engineers to develop and research for their product to make the better one. So among them, I'm very proud that Samsung has a managing director is Indian, Mr. Dipesh. It's for 7 years. Continuously grew up, continuously evaluated the best leaders of Samsung. So that's, frankly speaking, I'm very proud of that because he loves India, he loves Korea. So we wanted to build up those kind of relationship here in India. Now that we can say the semiconductor area, still, the Korean companies have not decided anything, I think, but now they can understand how much India is, ambitious to make the best of semiconductor, hubs for the market in global. So I think this kind of session and government's, the plan and strategic plan can contribute. A lot of the semiconductor companies, including Korea, Japan, Netherlands, Israel here, they can understand now. They have to understand now to come to India, to be a friend of India, for the people of India and for the people of the global. So hopefully this session can contribute on that point. Thank you.
Thank you, Ms. Kim. Thanks for that. Ambassador, very High Commissioner of Australia.
Thank you very much for the invitation to be here today, and congratulations to the Minister on the inaugural Semicon, because everything I hear is that it's terrific, and certainly Australia is delighted to have been invited. And to answer the question that I think the panel's meant to answer, is Australia is also up to cooperating with India, with other countries, whether through the Quad or bilaterally, to ensure that in this area we not only have competition within the world, but we have those secure supply chains that are necessary. The moderator was a bit generous to Australia at the start, saying that we had a critical role. It's a bit hard when there are fewer people in Australia than the number of 9-year-olds in India to suggest that we have a big input into anything. But we do have some niche capabilities around design, research and manufacture, and also silicon irradiation. But where I think we come into our own relates to critical minerals. Most people know Australia as a responsible and reliable resource partner. We've been blessed with critical minerals and rare earths. Most of the world's largest recoverable deposits of those exist within Australia. And our government has prioritised it by 2030. We're taking a leaf out of India's book. We've set ourselves a mission by 2030 to become a global player in relation to the supply of critical minerals that people in this room know are far more critical, not just to semiconductors, but so much of this emerging and critical technology than we could see. So we're already working, and we've worked with the United States on their 100-day review. We're working through the Quad on identifying and mapping supply chains across the Indo-Pacific. We're working bilaterally with India, and we'll continue to do so. The trade agreement signed only a few weeks ago gives India first shelf or top row access to investment in Australia, critical minerals and rare earth mines. And one of the Minister's colleagues is expected in Australia in June, along with Kabul, the arm in India that makes investments in these sectors. And at the same time, the Australian government is seeking to de-risk investment for people from overseas and within Australia to develop these mines, where the Australian government has put money on the table to accelerate development of this sector because of its importance. Why are we doing this? We're doing this principally because, as has been mentioned before, the world has changed over the last 4 years. We're doing this because of the health and economic lessons that came out of COVID. that supply chains and diversified supply chains and secure supply chains with reliable partners are more important than ever. I'm sorry to say this in front of my Netherlands colleague. We also learned the lesson of diversification. So I'm not suggesting Australia is about to get into the business of building chip manufacturing equipment, but it is one of the lessons that we learnt through that COVID period. So Australia can participate in a number of ways. It's determined to continue to work with India. We're establishing a consulate general here in Bengaluru because of the importance of the tech sector in this part of India. Importantly, we're establishing a joint centre of excellence on critical and emerging technologies policy with India because we want to work together with India and Australia and with other like-minded partners to ensure that the governance and the rules that are set up around these technologies internationally are rules that do what we in this room want, which is to enable people to fulfil their incredible ambition, not to be used for coercion. Australia also wants to continue to cooperate with India in relation to education. I regret that I'm sitting here as part of the second panel, which is all male. We in Australia, and I know in India, are working very hard to get more girls and women into STEM courses and opportunities because you can't lock out half of the potential in your country when it comes to any industry, let alone this industry where so many women have done so well in the past. We want to also ensure that under the national education policy, more Australians come here to be turned on to the opportunities that exist in India. I visited Israel last century, where it was made clear to me that that military service that is part and parcel, regrettably, of Israel's existence had also turned many young people on to the technology that's found within the defence forces of Israel. I'd like more Australians to come here to Bengaluru, to the other tech centres at Pune and the like, to see what is going on in this sector so that more of them will get involved. Australia has a history of good research that in past times has gone to a northern neighbour of India's. We're determined with a new breakthrough in relation to low-cost solar panels that will come here to India because that's the only country that can scale up and provide that competition. I think it does matter. The only thing that matters about whether a country's got complete control of a particular sector is how open and democratic its economy is. Taiwan poses no threats, but when autocratic nations get control of these things, they do tend to distort markets, and that's the other lesson out of COVID. So it's terrific to be here, it's terrific to participate. We do have opportunities which we want to pursue with India, with the world more broadly, and we're certainly up to the job of ensuring we have those critical supply chains that will guarantee that India's latest mission, its semiconductor mission, will not only be achieved because of the incredible talent that exists within this country, but also the agility and the willingness of industry to get behind government missions to deliver the outcomes. Thank you very much.
Thank you, Varric. Thank you for that stimulating presentation. Drew, this floor is yours.
Let me just say that it's a really incredible pleasure to be here. I would like to thank the Ministry of Electronics and Information Technology and the program organizers for inviting us to join Semicon and for convening this panel of trusted trading partners to discuss semiconductors, a product that I think we'll agree has become central to our lives. Try living your daily life without them, and a common focus, of course, to our countries. But first, I'd like to step back just for a quick second from the tech stuff, and I'd like to use this moment to reflect just a little bit on the U.S.-India partnership itself. This year marks the 75th anniversary of U.S.-India diplomatic relations. And from science and space to new and emerging technologies and protecting against cybercrime, to combating climate change, to finding clean sources of energy and protecting our oceans, and on to expanding our trade. There's no area of human endeavor right now that the United States isn't working on with India. And as the world continues to open, we have multiple engagements that we've held, including just last month, just a few weeks ago, we had the U.S.-India 2+2 ministerial dialogue, where Secretary of State Blinken and Secretary of Defense Austin welcomed Minister of Defense Rajnath Singh and Minister of External Affairs Dr. Jaishankar to Washington, D.C. And that was preceded by a virtual meeting between Prime Minister Modi and President Biden. And these and many more two-way visits show the high level of commitment to our enduring bilateral relationship. And then, of course, there's trade and investment, which has really long been at the heart of the U.S.-India relationship. Due to these ever-expanding ties over the last 2 decades, our bilateral trade in goods and services went from, in 2001, it was $20.7 billion, and last year it was almost $160 billion. So that exceeded the pre-pandemic trade record. In other words, it was a new record. Our bilateral trade has a really wide and lasting impact also on our economies and societies. And that relationship has just continued to expand over time. Most major U.S. firms, and many that you've heard from throughout this conference, of course, have significant investments and operations in India. And they have made the United States the largest source of foreign direct investment in India. And as the world's 2 largest democracies, our countries, the United States and India, also, we share a resolved commitment to protect our citizens, and we've helped to provide security and stability in the Indo-Pacific region that has underpinned our economic prosperity, and we're going to keep right on doing that. Also, just a really quick reference I would like to make, of course, to COVID-19, which has really, it's tested that resolve for all of us. But over the last 2 years and counting, the COVID-19 pandemic has really driven home the reality of our catalyzed reliance on technology and connectivity, and the disastrous effects of global trade disruptions that has been driven by the fallibility of our supply chains, which is another topic which directly bears upon why everyone is gathered here this weekend. And as all nations are seeking to revive economic growth, developing manufacturing and creating jobs, we believe India has a historic opportunity to fully integrate into Indo-Pacific supply chains, including of semiconductors, as investors and manufacturers increasingly seek alternatives to China in the wake of long-term rising costs and pandemic-driven instability. And as India saw in the 1990s, the more open an economy is, the faster it really grows. While we recognize that all countries are working to discern, what are the economic lessons that we've had from the pandemic, and we're all trying to figure out how to implement policies to promote economic recovery. We know that the benefits that U.S. companies have brought to bear in India, and we look forward to their continued participation in the Indian economy. And we were glad that Prime Minister Modi prioritized joining global and regional supply chains in his August 2020 Independence Day speech, and supported achieving this by improving India's business and investment environment. And then, as President Biden said last October at the Summit on Global Supply Chain Resilience, working together across the entire supply chain, from raw materials to warehousing and distribution, is really the best way to reduce delays and build in greater resilience for the future. And so let me just say now, before I wrap this up, that the United States sees 4 fundamental principles that encourage more resilient global supply chains. One is transparency. Improving transparency and information sharing will help all countries mitigate and respond to these global supply chain shocks. And this includes working with businesses to understand their own vulnerabilities, Transparency in supply chains promotes awareness of risks and potential shortages. It identifies bottlenecks and assists organizations in determining where alternative sources of critical inputs are needed. Next is diversity, openness, and predictability. Open global markets are fundamental in supporting resilient supply chains. Countries have to work together to ensure we have multiple reliable sources of raw materials, intermediate goods, and finished goods. Every country represented here today has a role to play in promoting that kind of shared benefit. Next is security. Countries discuss that security needs to be recognized as a high priority for all players with supply chains, especially in technology supply chains, at critical infrastructure nodes, other points within the supply chain that really must not fail to prevent damage or disruptions that interfere with critical systems or infrastructure. It's important that governments work with industry to better understand and manage security risks to supply chains. And then the last is sustainability. Governments, industry, and civil society should work together to promote and accelerate global sustainability goals, including implementation of the Paris Agreement on climate change and international labor and worker conventions where they're applicable. Creating fair, sustainable labor conditions strengthens our supply chains and it leads to more innovative, productive industry and greater shared prosperity. Finally, multilateral work with many of our partners here today has made supply chain resilience, especially for semiconductors, a very important part of our coordination. And we've seen that. Last year, the Biden administration expanded the reinvigoration of the Quad, which includes, of course, India, Japan, Australia, my country, with 2 leader-level summits. During the first ever in-person Quad Leaders Summit, we put forth ambitious initiatives to deepen our ties and advance practical cooperation on 21st century challenges, including COVID, promoting high standards infrastructure, combating the climate crisis, space and cybersecurity, cultivating next generation talent in our countries, and partnering on emerging technologies. And so with the Quad's Critical and Emerging Technology Working Group, we're using it to actively talk about semiconductor supply chains and how we can maximize the Quad as a partner for these kind of capabilities and resources. So to conclude, as trusted supply chain partners, all of us here have an opportunity to learn from the crisis that we've faced, whether it's working bilaterally, through the Indo-Pacific or through the Quad, building systems that support technology, including semiconductor manufacturing, will help guard us against future vulnerabilities, and it will really help strengthen our bonds. So again, thank you very much.
Thank you. Thank you, Drew. I think our panelists have been very disciplined. They all finished in 35 minutes. It's fantastic to have panelists like this for a moderator. So please think of various questions, short and brief and sharp pointers to the speakers. But before that, I just wanted to ask one short question to each of these speakers. So maybe we can do this like a quick fire round, as they say. Now, I mean, there is the Quad, which our 2 gentlemen to my right pointed out. But there is talk about another Quad, which Israel, India, US, and the United Arab Emirates want to form. And one of the central ideas was about innovation, where Israel is strong. And UAE and Israel have also worked on the chip production. So can you tell us briefly how that Quad might work on the chip production and what it can do to semiconductor mission here?
Yes, I think that we are witnessing, while the world is changing, also the Middle East is significantly changing. The Abraham Accords was a huge change where for many years, many countries a few countries in the Middle East had very good relations with Israel, but did it under the table, under the radar, as you would say, but now everything is in the open and much more convenient and comfortable to do. I believe that the world is also changing in the sense that countries are looking for regional alliances to promote. And the idea, by the way, of this Western Quad, or whatever name you can give it, the group of four, which is India, US, Israel, and UAE, is to work on infrastructure, but in a very wide definition of infrastructure with an emphasis on technology. So I think it's a wonderful combination because these are four countries that are very friendly. India brings in technology and a huge market. UAE brings in finances and ability to transport and build business, and the Americans are bringing the full package. We are the smallest player there, I believe, in many aspects, and we significantly, mainly bringing technology. So I believe that such alliances are extremely important for the future of our countries, of our relations, India and Israel, but also with other countries. And we have high hopes from this group, and many to follow later on.
Thank you. Kurt, if I might ask you, I mean, last week we had the European Commission President in town in Delhi. They've announced the Trade and Technology Council. I mean, these two areas were considered different, but today technology is very much part of it. So since we're the only European here, maybe you could tell us, because this is the only council, Europeans have only done it with the United States. So this is only with India that they formed. Can you just tell us in a nutshell to our audience what this Trade and Technology Council means?
Well, Europe is, of course, people are always a little confused about Europe, especially Americans have a little confusion about Europe because in North America is about the same size as Europe, about 10 million square kilometers. You only have 3 countries there if you include Mexico, and only 3 languages. And when you go to Europe, you have 51 countries and about as many languages. It's a very confusing place. So we're also one of the cradles of democracy, actually, in Europe. And we're looking forward to build up the cooperation in all fields, not only in technology, but in every field, with other democracies in the world. And India, of course, being the biggest democracy in the world, is a prime player in that whole field. Democracy is under pressure. I mean, there are fewer democratic countries now than there were 20 years ago, and some countries are obviously drifting in the wrong direction. So we, as like-minded countries, we need each other, and we need to cooperate in every possible field, technology as well as politics and economy more in general. We see a lot of investment flowing to each other. My country is the 3rd largest investor in India. India is the 4th largest investor in the Netherlands. That's not as impressive as the figures my American colleague just mentioned, but bear in mind that Holland is a small country. We only have 17 million people, not the 320 million of the US or the 1.4 billion that India has. And a lot of that investment flows to one state. When you look at the numbers from the Ministry of Trade in Delhi, you see that over the last quarter that we have information available, it was the first quarter of fiscal year 2021-22, 49% of all foreign direct investment flowing into India goes to one state, Karnataka. And my friend Karnatakans, and I'm one of them because I live also here in Karnataka, you're applauding for yourself, huh? Because you're doing an excellent job. And within Karnataka, most of that money flows to Bangalore, because when we talk about technology, it's mostly Bangalore, Pune and Hyderabad that are taking the lead in developing this country and making it a hub. And as I said before, it's crucial. We have to extend the technology in the world, and we have to extend the number of producers of semiconductors and other technology products. And of course, India is a prime candidate. A country like India that can build up space technology from scratch in just a few decades and now launches satellites for less than half the price than we do it in Europe or in the United States, well, such a country can also build up a semiconductor technology, and we're happy to cooperate with them.
Thank you. Let's turn to Dong Kyu Kim. I mean, look, Samsung is the key player, right, in the global production. What are Samsung's plans? Is it ready to come into India on this field?
Sorry, I cannot say the right away on that answer, that question. But private companies' decision is based on their judgment on the market risk and the opportunity. So that the important thing is how India can approach Samsung or other the Japan or the Taiwan companies to conglomerate of semiconductor business the leaders. how we can, the approach, how we can discuss, and then how we can show this opportunity safely. Is the important thing, I think. Yeah. Sorry, thank you.
Turning to you, Barry. I mean, I think one of the things Australia has done in the last few years is to develop the concept of resilient supply chains. Because you've been so tied to China. But now I think what's happened in the last 3 years, the lessons learned, the need to diversify, create resilient supply chains. How do we extend that concept, which India, Japan, and Australia talked about, into the Quad framework and more broadly into the coalition of like-minded countries?
I think it is happening, and as you say, post RCEP, Japan initiated an India, Australia, Japan effort on reliable, secure, whatever you want to call it, supply chains in critical areas, and that work is progressing. It's been progressed further by the Quad, but of course what the Quad brings to it is a desire to firstly map where the gaps are, where the risks are, and to start from that position. So that mapping has now been done, and that's where we'll start moving forward. But great opportunity for Australia and India, because we're not competitive economies, we are complementary economies. We have inputs like metallic coal to assist the steel industry here to deliver the infrastructure. How serious we are. So, critical minerals was one of those matters that Prime Ministers Modi and Morrison discussed in their summit, virtual summit in June of 2020. We put together a report on critical minerals. We identified and mapped the critical minerals we thought that India would need. And only this year we have adapted that to include high purity alumina and silicon, precisely because of what we're seeing happening here in India in terms of the policy announcements around these areas. So, it's not a case of build it and they will come. It's a case of India announcing another mission, and Australia and other countries, frankly, reliable partners working together to deliver the supply chains. Because when India develops an industry, in this case semiconductors, but in other spaces electric vehicles and battery storage, it provides that international competition that delivers better prices for other countries, and delivers also that free trade that Drew was talking about, that basically provides the world with greater certainty. So that's how practically we're trying to do it.
Drew, you talked about the Quad and the new technological partnerships that the last 2 summits talked about, September 2021 and recently the virtual summit. Now we are actually just 3 weeks away from the next summit in Tokyo, where the 4 leaders are going to meet, that is US, India, Japan, and Australia. Can you give us a preview of, I'm not putting you on a spot, but generally the direction on the semiconductor side, where we can go for the next stage in the summit?
Well, that's a great question, and I won't predict or try to prognosticate about the exact items on the agenda. As you know, as a real expert in the international relations sphere, these things often they're finalizing in right up in the run-up to it exactly how much they can accomplish or how much they're going to do. But it's really. If we think about the Quad and what the countries in it have been able to do, it's really breathtaking. Like 4 years or so ago, it was meeting for the first time in a while at the assistant secretary level. And now we've had several leader meetings, as you say. But with respect specifically to the topics that we're on here, it's amazing how much the Quad has reflected the fact that our strategic competition has become totally economic. The Quad really used to be about some other topics and maybe a little bit this, but if we look, since our new administration in my country, every new leader-level working group that's been introduced in the Quad is 100% about this, strategic economic competition. And so I think you can see a lot in the Quad countries, as you pointed to. Each of them really have strengths in the semiconductor area, and so whether it's more work on design or any number of other things, I mean, it's hard to, it's hard for me to be able to predict here exactly, but I'm certain, given the importance of the supply chain resilience that we've talked about, that it's going to be a continued focus, if not an increased focus of the Quad, and let's see what happens in Tokyo in a few weeks.
Thank you. I think we now have about 10 odd minutes for questions. So I saw one hand there. Pranay. Is it Pranay? Can you just introduce yourself?
Hello, everyone. I'm Pranay. I work on semiconductor geopolitics. It's great to talk to you about this. So my question was that, there is a lot of talk about building national capabilities, which is very much required. But as of what I can understand, building a resilient supply chain requires multilateral cooperation, right? That's a necessity and not a choice. So from that angle, are there any collaborations in place or being worked out to, let's say, start a prototyping fab where all the smaller companies can try to reduce their time to market? Or are there plans to set up new center for excellence in materials or new architectures? So that was my question to all the panelists. Thank you.
Thank you. I think hold your thoughts. Are we going to take some? Nivruti wanted to.
India is investing 10 billion already. It would be lovely to see how we can come up with a central partnership engagement model to build self-sustaining semiconductor ecosystem. That would, be lovely to see with all of our partnerships.
Anyone else? I can take. Yeah. So,
hi.
Please introduce yourself and be brief.
Yeah, my name is Ananta Bhatt. I am in the skilling industry. Especially to requesting the US representative, do you see that in next few years, the US universities can have a presence in India? There are cases of top US universities being in Middle East. With appropriate policy change, can we see Stanfords and Berkeleys and MITs having the branches in India down the lane in next few decades, or next few years preferably?
Okay, so we'll take those three questions. You want to start? We'll go this way.
One more comment before you answer.
Okay.
My name is Erez Zimmerman. I'm from Tower Semiconductor, Israel. Okay. And my question is complementary to Nivruti, and especially for a gentleman from the Netherlands. So we all know that you are holding the supply chain by ASML lead time right now. And this is really interesting to know how ASML will release this bottleneck for the entire industry to getting ramped up. Because right now, as we all know, having an ASML machine is more than a year and a half lead time or so. So this will be very interesting, very important point.
Yeah. Anyone wants to come across? Barry, anything?
Look, I'm simply happy to repeat in relation to the supply chains that, India's putting an enormous amount of money on the table to develop its semiconductor mission. The Australian government is doing likewise to get the mineral supply, the critical minerals and rare earth supply, up to scratch, out of the ground and processed to be able to put in place with other countries those supply chains for those resources. You're right, it involves lots of countries, but I've noticed as a former politician, recovering politician who's playing diplomat in this country, that the more countries that are involved, the larger the multilateral forum, the slower it is. So I'm happy to keep cooperating with India and Japan and within the Quad to get something practical delivered. Politicians and ex-politicians are always transactional rather than simply forums of talking about it.
There was one question on universities. I think you should address the question to the minister and largely outside. I mean, I think it's really, it depends on what we do. I mean, I think we've been talking about this for really 20 years, hoping that at some stage, but I think the new economic policy has provisions for it, of setting up world-class universities in India. And to some extent, there have been collaborations, as you know, between different institutions. And I think as the economies of of India and the US and India and the West more broadly come together, and there is greater collaboration in technology areas, I think it is a question of time. I mean, how you bring in the question of talent has been addressed in this semiconductor summit. And it is a question of, the market forces themselves are going to drive. Either you send them all to the US, pay big money to the universities, or get some of the universities here. I mean, either outsource students or get the in-source students. I mean, I think it is going to be inevitable that we're going to create the policy conditions for greater exchanges within the high technology domain. Australia is another major destination. You wanted to come in on that?
Well, I was simply going to say that there is enormous interest amongst Australian universities, which are, again, smaller than US and UK universities and to some degree a bit cheaper, even though the quality is the same. That's just a commercial. As of January, we have 360,000 students from India studying at our universities. And those universities in Australia are also keen to have Australians studying here. And Minister, providing the National Education Policy regulations match the ambition and the statements in the policy, I think you will see those dual degrees, those institutions looking more closely about and establishing presence here in India.
Any other questions on the floor?
Just a question to the Ambassador of US.
Just introduce yourself.
My name is Murli. We're working in the space of active mobility, cycling, sustainable mobility. So we are collaborating already with MIT and Stanford universities. So basically, what we realized is it's let's say making of a cycle, simple cycle itself, right? So there is a product realization lab in Stanford University where they teach the students how to design the cycle, understand the mathematics of the cycle, and the student will design and take that cycle on a tour. Okay, that is the first semester kind of like things, right? So what I realized is in our universities, there is not much focus on practical things translating immediately. There's no realization of what we're learning, right? So I'm just requesting, is there a possibility that we identify these critical, whether it's semiconductors, where there is actually need for putting your hands and getting some practical insights, right? Identify these very critical professors and kind of have these kind of industries also there and kind of have a stack wherein we can interact with these professors and make that learning curve faster with these direct interactions.
But I think the question is really about how do we create conditions within ourselves. I mean, that's a task for ourselves, and I would really say, in some senses, I mean, the last few years we've seen, the semiconductor mission is one example, of creating domestic conditions for raising to the next level, raising the Indian economy to the next level. I mean, everyone agrees knowledge economy, technologically driven economy, that those are the goals. But the policy environment has not facilitated in that past. That's why you had everyone going out and doing things. But today, as the semiconductor mission points out, to create conditions for producing in India. I mean, that is the meaning of, say, Atmanirbhar Bharat today. This is not the self-reliance of the 1970s. This is one of producing in India and producing for the world through partnerships. In the 70s, we really shut ourselves down completely. Many of you might not born before that time, but we threw out IBM from India to our credit, so that was needed some genius. But there we were. I mean, I think it is our domestic policies that actually pushed ourselves out. But today, I think the conscious pursuit, both on the EV side and on the semiconductor mission, I think it's even more grander in scope, that of creating domestic, because there is international capital, there is technological capability, there is a political will among India's friends to work with India. So I think all that is needed is to really create the conditions for making India a semiconductor hub. I mean, I think all of you have heard in the last few minutes words like trusted partners, resilient supply chains, because as I said, this is not going to be anyone can make anywhere, that it has to be among friends. It has to be among trusted partners, and that we can work this in a way that a globalized way, not in the post-1990 sense, but a globalized structure among trusted partners that can deliver the goods for everyone's benefit. And that is the broad idea. And I think the semiconductor mission is trying to capitalize on that, both by creating conditions at home and by embarking on partnerships with critical countries. And I think that's why, if this is one of the most exciting missions that India has launched, we really wish Minister Rajiv Chandrasekhar great good luck in this, because I think I see the stars are getting aligned, both in terms of India's domestic policy environment, the political context in which India is today much closer to the West and those partners who are today, there is capital available, and there is problems that were created by certain countries have actually created, you couldn't get better circumstances than these to actually take this semiconductor mission off the ground. But I would conclude by saying the governments can facilitate. The government's job is to create a policy environment in which new things can happen. Bring in the foreign policy elements into it, bring in the domestic policy aligned with the possibilities that exist. But in the end, this still has to be done by B2B, scientist to scientist. And I think here we have a lot of strengths. India is already globalized in a way. Indian scientists everywhere in our friends, I mean in North America, in Europe, in Australia. So you have actually a natural talent pool already distributed among the key partners. So therefore I think we're really poised. And here, that's why I would simply say, I want all of you to join me in thanking our panelists for giving us such a wonderful session. And also wishing the Minister and the Semiconductor Mission a grand international success. It's not just, we need foreign policy to make domestic economy succeed. Actually, the domestic economy, if it's going to do well, it's going to change the world as well. So let's stop here and thank the Minister. Thank you all for your patience.
Sincere thanks to all the dignitaries for making this a great success. And thank you very much for being here. It's about India's role in global semiconductor supply chain. We have Mr. John Neufer, who has already joined us online. He's the President and CEO of the Semiconductor Industry Association, which has been the voice of the chip industry for over 4 decades. He has been the nexus of technology, public policy, and trade. He also serves as a member of the Board of Directors of the Semiconductor Research Corporation, the world's leading non-profit industry government academia microelectronics research consortium. So ladies and gentlemen, please put your hands together for Mr. John Neufer, who is going to take us through this session for the next 15 minutes or so. Hello, sir.
Hello, everyone.
Welcome.
It's a great pleasure to be here.
Yeah.
I would like to thank the Ministry of Electronics and Information Technology for envisioning this unique platform and inviting the Semiconductor Industry Association based in Washington, D.C. to share our perspectives with you. I'm John Neufer, President and CEO of SIA. SIA is the voice of the semiconductor industry, one of America's top export industries and a key driver of America's economic strength, national security, and global competitiveness. The U.S. semiconductor industry directly employs over 250,000 workers in the United States, with sales totaling nearly $260 billion last year. SIA represents 99% of the U.S. semiconductor industry and nearly 2/3 of non-U.S. chip firms. Just a couple weeks ago, I, along with several of my SIA colleagues, had the great pleasure to travel to India for an exploratory visit to learn more about this country's policy ecosystem, your efforts to strengthen your role within the global semiconductor value chain, and learn more about your private sector. In fact, that visit was the very first overseas visit by us in over 2 years. We had the great pleasure to meet on that visit with Minister of Economics and Information Technology Vaishnaw, Minister of State Chandrasekhar, Minister of Commerce and Industry Goyal, as well as secretaries leading the various departments. These meetings in New Delhi and Bengaluru were encouraging and highly informative. We saw the enthusiasm, commitment, and potential India has to contribute more to the global semiconductor supply chain. Then, shortly after returning to the United States, we also had the honor of meeting Finance Minister Sitharaman to discuss the potential of India's IT sector. We welcome the pioneering vision of the government of India and Prime Minister Modi to develop a sustainable semiconductor and display manufacturing ecosystem in this country. The announcement of the $10 billion incentive plan is a visionary step toward making India a key hub within the global semiconductor value chain. The semiconductor industry is both essential to all of us and truly global. The global chip shortage has reminded everyone that semiconductors are now embedded in virtually everything in the modern economy with an electric current flowing through it. And the industry has become so global that in today's interconnected world, no country can or should attempt to fully indigenize our complex semiconductor supply chains within its border. The need for deep technical know-how and expertise has resulted in a highly specialized global value chain where regions and countries perform different roles according to their comparative advantages. All countries, including the US, are interdependent in this integrated global value chain, relying on free trade to move materials, equipment, intellectual property, and products around the world to the optimal location for performing each activity. From the time a chip is developed to the time its manufacturing is complete, it literally crosses dozens of borders. The way forward is to enhance the nation's position within, not outside, the global semiconductor value chain. India has a tremendous opportunity in this regard, and we fully support your endeavor to upgrade your semiconductor ecosystem by more deeply integrating into these global value chains. Global collaboration is the only way forward. Already, India is a critical hub in the semiconductor value chain. Roughly 20% of the world's semiconductor design workforce is located here in India, and many, if not all, of the world's chips include some form of contribution from India. This is a tremendous asset. India and the United States have already collaborate in semiconductor research and development. The Semiconductor Research Corporation, located in the United States, and more than a half a dozen Indian research institutes are collaborating on joint R&D projects. You're all well aware that India has many unique assets, including a skilled workforce, competitive labor costs, and abundant innovation. And SIA would like to help build on those assets to further India's goal of creating a robust semiconductor manufacturing sector. Today, India accounts for 1% of global trade in semiconductors and 0.5% of global semiconductor sales. While admittedly starting at a low base, India's role in trade and sales of semiconductors has grown impressively. Integrated circuit imports into India from 2015 to 2018 jumped by a whopping 218% to $8 billion. In 2021, India's integrated circuit imports grew to $12 billion. And today, the broader Indian ICT market is burgeoning, accounting for nearly $150 billion in total sales, with growth projected to accelerate over the next decade. For example, in 2021, India accounted for 12% of global smartphone sales. As a result, an increasing amount of original design manufacturer electronics assembly is happening in India, which will provide a stronger incentive for more upstream electronics investment. Many countries are seeking to invest more in manufacturing semiconductors domestically and are offering significant incentives to achieve this objective. We welcome India's goal of becoming both a more powerful digital economy and a hub for electronics and semiconductor innovation within the global value chain. We really think India has an opportunity here to make targeted investments to enhance the competitiveness of its domestic semiconductor ecosystem across all segments: research, design, manufacturing, and assembly test. I'll add that a semiconductor ecosystem within India that is welcoming to all firms and forms of business models and partnerships is likely to be the most successful. In the US, SIA has long advocated for and will continue to promote the importance of maintaining and strengthening global supply chains. Our goals within our own country are to invest further into developing chip design and manufacturing capabilities, and to help our allies and partners also increase their capabilities. SIA plans to continue our dialogue here and would welcome the opportunity to help our companies better understand the government's incentive schemes. India's Semicon program, with an outlay of $10 billion US, has various initiatives that have been introduced for strengthening the semiconductor and display ecosystem in this country and have the potential to position India as a more important player on the semiconductor map of the world. As I look forward to collaborating more with India to promote a healthy global semiconductor value chain that embraces open competition, protection of intellectual property, and strong global trade rules. We look forward to India's commitment to further economic development and the opportunities it would bring for both U.S. and Indian firms alike. Platforms such as this, India's first Semicon conference that touches upon the nuances and complexities of the semiconductor ecosystem, put under one big, wonderful tent the key stakeholders from government, industry, and academia. This event helps light the pathway to a bright and comprehensive semicon ecosystem in India. We very much look forward to witnessing and supporting the next phase in India's great semiconductor journey. Thank you.
Penultimate deliberation from Prabhu Raja, Applied Materials, about semi-equipment perspective in mission mode. Mr. Prabhu Raja, as you can see on your screens, leads Applied Materials Semiconductor Process Equipment Business and Global Field Organization. And without much ado, straight away over to Dr. Prabhu Raja, Senior Vice President, Semiconductor Products Group, Applied Materials. Over to you, Dr. Prabhu Raja. Are you there? Yeah,
Thank
can you hear me?
Yes, I can hear you.
Yeah, please go ahead, sir.
Thank you for the kind introduction. Today I'm going to talk about semiconductor manufacturing from equipment perspective. And just a brief introduction about Applied Materials. We are world's #1 in semiconductor and display equipment, and with the $23 billion in 2021, and we spend around more than $2.5 billion in R&Ds. We are over 19,000 countries, and particularly we have 15,000 patents more than and 12,000 in process. Every single day, even including weekend, we generate 4 different patents every day we generate. And with that, the key messages I want to give, how you heard about this AI semiconductor manufacturing, what challenges it's bringing for semiconductor manufacturing, how equipment and process innovation, what we do, are enabling those semi-manufacturing. And we are expanding in Applied Materials in India, particularly on product innovation commercialization. I want to talk about 3 topics. Particularly the first one, remember many devices you guys have seen, the clocks and what's video cameras, all have gone into one smartphone, replaced all of them. Today's big devices, you look at this computers and the cars and phones and many, many small devices, all have become AI-centric world. And the human and the AI are very closely connected right now. And in fact, in the future, this AI will be enabling the human even more. And, really look at those semi-industry. We saw the 4 big waves of growth, starting from mainframe to PC era to mobilities. Today, we are at AI era, the early stage of AI era. By far the biggest one. It would go up to $1 trillion semi-revenue by 2030. And the billions of devices are connected through this. You must have heard many times, and again, this AI happens both in cloud and also on the edge. It's enabled by wide range of semiconductor, not just logic devices. You can logic, memory, DRAM, NAND, packaging, power semi, compound semi, and image sensor. All the wide range of devices are enabling this artificial intelligence. You must have seen this. This transformed the entire industry, health industry, transportation, entertainment. You see it day in, day out, how AI is transforming today. It comes with a lot of challenges. You can see one of the biggest challenges, what we see, the power consumption challenges, both in edge as well as the cloud. If you really look at the edge alone, even if you take this camera, smart cameras you see all over, in some countries, you can see more than 500 million units, and the power it consumes, even the cameras alone, equivalent to 1 US nuclear power plant power energy generated by this nuclear plant. If you go to this AI data centers, you can see that training plus interference combined together, 15 to 20% of global electricity by 2025 would be consumed by AI alone. This is absolutely not sustainable. That today's way of doing semiconductor is not going to address these challenges. So you need new semiconductors with a lower power consumption, higher performance, smaller areas, lower cost, and more importantly, speed, faster time to market. So industry is a playbook, what we call it, PPACT, power, performance, area, cost, and time to market. This is the industry new playbook. You know, this is enabled by, you can see multiple inflection happening in the semi industry, new architectures, new structures, everything's going 3Ds, new materials, new ways of strength, advanced packaging. You must have heard all about this. These are all enabling this PPACT strategy. The foundation for all those things is materials engineering. And I want to give one example in advanced packaging. Is advanced packaging. Multiple chips are connected together as one chip. They're very closely connected. The processors and also the memories are closely connected. They have huge performance gain and lower power. I just want to run a video how it looks.
Here is an advanced package integrating logic and memory chips. A substrate connects the package to the external motherboard. Further up, a silicon interposer serves as a foundational connector with spherical bumps, long copper columns known as through-silicon vias, and multi-tier copper wiring, or redistribution layers. Moving higher, we see the vertical stacking of individual memory chips with through-silicon vias and micro-bump connections. Switching to the logic side, we see chiplets connected to the interposer by through-oxide copper vias and micro-bumps. Further inside, SRAM chiplets are connected to the AI logic die on top with copper hybrid bonding. Redistribution layers and through-silicon vias connect the SRAM die back to the interposer, completing the package connections. In summary, logic chiplets and towering DRAM memory stacks are connected as a system.
Assume packaging is simple. It's not that simple. It's complex. Imagine the complexity is what we see. It is semiconductor manufacturing. And next section, I want to talk about how our equipment and process innovations are enabling the semi-manufacturing. Really look at it. You take an iPhone, you really look at the processor which is driving A15 phone. You'll see, if you cross-section those one, you'll see multiple layers of materials in the different shapes. You can see that. What it has is more than 15 billion transistors and more than 90 kilometers of wiring it has got inside right now. Why I'm talking about? I'll talk about those challenges it brings. And what does it take to do this, process this? You need more than 1,000 process steps. It takes 2 months long. The wafer keeps running through the 2 months long. It requires multiple equipment capabilities. These materials need to be deposited. Materials need to be shaped. Materials need to be removed. Materials need to be modified and treated many times. And also you need a lot of analysis. At the top of it, also lithography. In applied materials, we have 60 product families to address this. And one of those equipment, I have it here, this is a state-of-art equipment. We call it Endura deposition product. And it's a pretty complex and which done atomic layer level. It can do multiple steps under vacuum. And I can tell you that every advanced chip today, it runs through this machine at least once, in most cases multiple times. So what are the complexity we see in our equipment? The simple example, if you take one transistor, which is 20 nanometers dimension, and the gate is 20 nanometers. What is 20 nanometer? How small is 20 nanometer? You can see human hair is 60,000 nanometers. And you can see the red blood cell is almost 7,000, and even human DNA with these 3 nanometers. So within these 20 nanometers, we put 6 to 7 different materials. A lot of them are nanomaterials. They're 1 or 2 nanometers thickness into the small dimension. It requires atomic level processing. Every atom matters. It's extremely complex, atomic level processing. Imagine you do atomic level processing on an industry scale. We talked about single transistor complexity. You have 15 billion transistors. Imagine you have 400 chips in a wafer. You have 100,000 wafers per month in 1 giga fab. You can imagine how many fabs we have, gigafabs, or multiple fabs we have in this world. So we got to do this atomic level processing in industry scale day in, day out. Every atom matters. What it requires to develop equipment? A lot of innovations and commercializations. Innovations. You need lots and lots of expertise, foundation science, university partnership, concept and feasibility labs. In terms of commercialization, multidisciplinary engineering. You study any electrical, mechanical, software, data science, think about anything you need. Manufacturing capabilities, supply chain ecosystems, and also customer support. You need a really commercialization. That is the foundation. I just want to give an example of applied equipment process innovations. What do we do? 2 good examples. One, the biggest problem industry is facing is wiring resistance. Why? The huge power loss from wiring resistance when you go to smaller and smaller dimensions. 1/3 of chips power is consumed in wiring. On the left-hand side, you can see those. 1 layer, if you take a 1 layer, 1 single metal layer, you can see that is 30 nanometer in size. On the right-hand side, you can see the node over node, what is the wiring resistance. It increases exponentially. That means a huge power loss is not sustainable. I want to show that one of the applied innovation is helping. You'll see on the left-hand side, the equipment, you see the animation, how the wafer is moving through from one process to other process. Just to deposit 1 metal layer, it has to go through multiple layers, multiple process, interface engineering, selective ALD depositions. Look through metrology, make sure it's okay. You have to treat the materials. Liner depositions. You can imagine what kind of complexity it does, and all has to be done under ultra vacuum. These wafers from one step to other step cannot be taken out of the vacuum. Imagine you have 1 nanometer. The material is not the same when it comes out exposed to air. So you can see the innovation. What does it do? The same plot what I showed that. 50% lower resistance by doing this. Again, imagine 50% lower resistance, the billions of VR connections. And even if you take 5 critical layers, it's a huge power savings. These innovations can make a big difference. Another example is in the transistor side. The transistor leakage. You all know that your phone, the powers don't last for a longer time, few hours. You can see that, and the phone gets hot. It's all coming from the transistor leakage. On the right-hand side, I put transistor leakage versus gate dielectric dimension. When you go to smaller nodes, you are on the right-hand side. In this plot, you can see your lower is good, upper is bad. You can go more. Industry has seen this problem once. The leakage kept increasing, made a big changes in the materials innovation, high-k metal gate, again starting to go up in a smaller node. Industry is struggling today. So what we have in applied, the process and materials innovation. We can have up to 1000x leakage reduction by modifying 1 layer, 1 atomic layer by modifying. We can see that is a huge innovation, big innovation. Imagine these leakages in 1 single transistor times 15 billion transistor. It's a huge power savings, or you can call it transistor speed increases by 20%. These are some of the big innovation I want to share with you. With that, I want to move on to what are the opportunities we have in India and why we are expanding in applied materials in India for product development. A brief introduction, Applied Materials India, we have 6,000 employees and 5 different locations. We have very, very strong partnership with the premier universities in India. A lot of capabilities in science and engineering. I think we are creating around 450 patents overall we developed so far, US patents. And also, you know that I announced that what we are investing in India, 340 crores for new infrastructure, also 1,500 crores for product development, innovation, commercialization next 5 years. What does it take for process developments and developing a product? Multidisciplinary science and engineering, data science, labs and plasmas, lots and lots of capabilities. Where you see the green circles are the places we already developed the capabilities. We have a capability today. India is helping us for product development here right now. The white or the circles are the places where we are focusing. That's where I was talking about expanding in India, investing in India to develop those capabilities, product development capabilities out of India. If you really look at those for India, it's a time of big opportunities in India. The conventional manufacturing today is growing. Demand is high. All logic, memory, everything is growing. On the top of it, there's a new manufacturing needs in legacy node, IoTs, compound semi. I think we talked about multiple times, image sensor, packaging, the new manufacturing needs. If you really go and summarize everything, the market is growing, the demand is there, and also a lot of new manufacturing opportunities are opening up. AI is bringing lots and lots of challenges, and it needs a deep technical talent where India has plenty. And with the government supports on right now on policies, I think it's truly India's time to shine. Thank you.
Thank you, sir. A couple of questions? I think we can take a couple of questions, if any. Anyone? Yeah. Yeah. Straight away come to the question, please. Yeah.
Hi, I'm Manoj from SCL, Chandigarh. I think we have been discussing about the equipment lead times recently. So can you now comment what will the lead time for Endura systems now?
You know, see, they all depend how we prioritize. You know, the demand is huge, high, I can tell you, very high demand. And everyone has supply chain challenges, and we are going through those supply chain challenges. We are learning a lot, and we are solving a lot of those problems. So you can see one of our biggest challenges is even the chips. We need chips to manufacture the equipments, and one of the bottlenecks for our customer is our own equipments to make chips, right? Our customers are helping us with the chips. I think today doesn't matter based on priority. I think we always think that we should be able to do it within a year. Yeah.
Any other questions? No? Yeah. Thank you, Mr. Prabharaja, for taking time off and being amongst us. Thank you very much for joining us on the virtual mode.
Thank you.
Well, we now move on to the final conclusion stage. And it's my privilege and pleasure to request the chairman of the steering committee of Semicon India 2022, the Honorable Minister of State for Electronics and Information Technology and Skill Development and Entrepreneurship, Government of India. In a short while from now, he would be addressing us and yeah, it's on demand, madam. Yes, Ms. Maya Jagdish to kindly come over. And yes, it's a suspense. Yeah, it's a different welcome suspense. So put your hands together for her.
Well, I was thinking the conversation that happened between our minister and Raja Koduri would be forgotten on day one, but it's not. By the way, it was my privilege to inaugurate, to start this event, this wonderful event, by lighting the lamp. And today, as with the Indian custom and culture, we typically start with something very auspicious by seeking the blessings of Almighty. And ending also has to be something very auspicious. So I'm a trained classical music vocalist, and I'm here to sing a few auspicious verses. These are called Mangala Shlokas, taken from Srimad Bhagavatam, which is a scripture written in glory of Lord Krishna. These verses are very special to me because these were actually composed by my grandfather, Subramanya Shastri, who was a Sanskrit scholar. So I'll make an attempt to sing these verses and seek the blessings of Almighty again, so this auspicious ending can lead to many other auspicious beginnings. Satyajnanaswarupaya Vishwotpatyadihetave Tapatraya Vinashaya Shri Krishnayastu Mangalam Dushtakamsabhayakshetre Shishupaladiध्वंसिने Jarasandha Vimokshaya Shri Krishnayastu Mangalam Yogignanavaranyaya Nirmalajnanamurtaye Devahuti Suputraya Kapilayastu Mangalam Kardamagnana Bodhaya Nityajnana Swarupine Bhaktaharda Tamashetre Kapilayastu Mangalam Narayana Swarupaya Sankhyajadyaya Yogine Samsara Bhayahartre Cha Kapilayastu Mangalam Dayamayo Harisakshat Matuh Priyachikishaya Ajanmapi Bhavam Bheje Kapilayastu Mangalam. Thank you.
Well, ladies and gentlemen, we all know Sanskrit is the bhasha of devatas. So by remembering all the devatas on behalf of all of us, it's indeed a very special moment for all of us. I think we should give a huge round of applause for Madam there. Well, we now move on to the final conclusion stage. And it's my privilege and pleasure to request the Chairman of the Steering Committee of Semicon India 2022, the Honorable Minister of State for Electronics and Information Technology and Skill Development and Entrepreneurship, Government of India. In a short while from now, he would be addressing us and Yeah, it's on demand, madam. Yes, Ms. Maya Jagdish to kindly come over. And yes, it's a suspense. Yeah, it's a different welcome suspense. So put your hands together for her.
Well, I was thinking the conversation that happened between our minister and Raja Koduri would be forgotten on day one, but it's not. By the way, it was my privilege to inaugurate, to start this event, this wonderful event, by lighting the lamp. And today, as with the Indian custom and culture, we typically start with something very auspicious by seeking the blessings of Almighty. And ending also has to be something very auspicious. So I'm a trained classical music vocalist, and I'm here to sing a few auspicious verses. These are called Mangala Shlokas, taken from Srimad Bhagavatam, which is a scripture written in glory of Lord Krishna. These verses are very special to me because these were actually composed by my grandfather, Subramanya Shastri, who was a Sanskrit scholar. So I'll make an attempt to sing these verses and seek the blessings of Almighty again, so this auspicious ending can lead to many other auspicious beginnings. Satyajnanaswarupaya Vishwotpatyadihetave Tapatraya Vinashaya Shri Krishnayastu Mangalam Dushtakamsabhayakshetre Shishupaladiध्वंसिने Jarasandha Vimokshaya Shri Krishnayastu Mangalam Yogi Jnanavarenyaya Nirmala Jnanamurtaye Devahuti Suputraya Kapilayastu Mangalam Kardamajnana Bodhaya Nityajnana Swarupine Bhaktaharda Tamashetre Kapilayastu Mangalam Narayana Swarupaya Sankhyajagyaya Yogine Samsara Bhayahartre Cha Kapilayastu Mangalam Dayamayo Harisakshat Matuh Priyachikishaya Ajanmapi Bhavam Bheje Kapilayastu Mangalam Thank you.
Well, ladies and gentlemen, we all know Sanskrit is the bhasha of devatas. So by remembering all the devatas on behalf of all of us, it's indeed a very special moment for all of us. I think we should give a huge round of applause for Madam there. Thank you very much. And with such a great backdrop for the concluding remarks, we are all set all set to welcome the Honorable Minister of State and also importantly the Chairman of the Steering Committee. Ladies and gentlemen, put your hands together and welcome Sri Rajiv Johnson.
Namaskara and good afternoon. On that beautiful note, I think it is time to draw the curtain on what has been 3 days of very inspiring, very energetic, and very illuminating conversations about our mission to catalyze India's semiconductor ecosystem. I will not speak for too long. It's been 3 days, and I'm sure that most of you who have traveled from far have to get back. Tomorrow is a Monday. I'll just quickly say a few points. One of the best ways to characterize a success or failure of a conference is the intensity or the interest or the freshness of each day. And Vrindham, I think he's not here anymore, he was telling me that he has never attended a 3-day conference like this where every day he was looking forward to every session. And I think that is in itself a testimony to the quality of this Semicon India 2022, the inaugural Semicon India 2022. And let me start by just thanking each and every member of the steering committee, my colleagues in the ministry, and indeed every one of the industry stakeholders who worked very hard to make this inaugural Semicon India a success. Again, let me just quote, 2 young engineers walked up to me at the end of day 1 as we were moving to dinner, and they said to me that this, according to them, actually it was the second day, yesterday, and they said to me that this is the best collection of high-tech leaders that they have ever been part of. So I think that is again a testimony to the very high quality of conversations around compute, around AI, semiconductors, the future of systems architecture, talent, fab, that characterize these 3 days. The MOUs you also have heard of and read about. Those MOUs also summarize many of the leading foundational elements of this conference on manufacturing, talent, design and manufacturing, and partnerships. I can assure you that on behalf of our Honorable Prime Minister and the government, and he made that very inspiring speech on day 1, and he set the bar for all of us in government, which is that the government is an AND gate and not a NOT gate. I can assure you that we will play the role of an AND gate for this ecosystem. Our mission is our Honorable Prime Minister's vision. We are very, very determined as a team, as a nation, as a people, to ensure that his vision of making India a player, a significant player in the global supply chains for semiconductor is actualized and realized in the coming months and years. I will say what I said in yesterday's press conference to end this whole 3-day Semicon India conference. It used to be that the world used to say, my system is powered by AMD, my system is powered by Intel, my system is powered by NXP, my system is powered by TI, Infineon, NVIDIA, as the case may be. And Microtech, I noticed Microtech is there. But what I think the vision now for us, the mission for all of us is that regardless of which platform, regardless of which brand, which company, regardless of whether it's a global company or an Indian startup, whether it is a DIR5 product or an ARM product or an x86 ISA, that we should be in the coming years be able to say that my system is being powered by India inside. And I think that is the goal. That is a thought I will leave you. That is a thought I want to leave in all of your minds, that our mission is to make sure that India is inside all of our future systems. Thank you all again for participating, for engaging, for conversing, and contributing today. And I hope you will continue to do this in realizing and actualizing our Honorable Prime Minister's vision and India's vision to make India's ecosystem, semiconductor ecosystem, a significant partner to the global supply chains. Thank you. Jai Hind.
The team of Mighty, all the members kindly come over for a photograph with the Honorable Minister.
I'll also request ISA, VLSI Society members to come over who have supported in this program. Without their help, it was not possible to conduct this. Please come over.
Mr. Amitesh ji.
Amitesh ji, can you come up here? And go on to the making India semiconductor mission successful. On behalf of the whole industry, I want to thank Amitesh ji. एक मिनट अभी क्या बोले 25th March, Government of India announced that he will be taking over the activities in the semiconductor, and today is what 1st May, right? In short span of 35 days, he has not only learned the ecosystem and so much about semiconductor, but he has put so much effort in making this conference successful. 2 a.m., 3 a.m., he will be sending a WhatsApp. Oh, not just generally, in that session, that particular panelist is not the right guy. Can you get this guy, right? So involved, so basically, I think, looking at all aspects of the conference, right? So on behalf of everybody, I just want to thank Amitesh ji, and he wants to sit with us.
So actually nothing to thank about it. I'm getting salary for that. But it's a Team India kind of activity that we have just seen. And everybody, whether industry leaders whom we have approached in a short notice of 2 days, 3 days, 5 days, they all agreed. And because of their cooperation only this could happen. So I want to thank all such industry leaders, all industry associations, the person in MATI, my officers, my colleagues, my friends, and ultimately the leadership of both the Minister, Ashwini Vaishnav sir and Rajiv Chandrasekhar sir. So both of them had very given free hand to us to organize this. They guided also from the front, and as a result, this could happen. So I thank everybody, and I want to assure that MATI will be a new kind of MATI. It will be hand-holding industry, and we will try to facilitate all the activities which is required for semiconductor mission. And I'm always available for any kind of advice, help, suggestions. I'm looking forward to learning from you because I'm a new kid in this semiconductor business. So please educate me, and I'm open to that. Thank you. इसको ऑन करो. Hello. We have just missed the person who has done this, Mr. Jagdish. Where are you? Please come here. So the agency name is Active, and as per their name, they are very active because in such a short period of time. So here is Mr. Jagdish.
Me and my entire team, of course. They're all here. Thank you.
So before we depart, as you see, the tagline of the conference was catalyzing the semiconductor ecosystem. So when you mix the right ingredient in the chemistry lab as a catalyst, right, it becomes explosion. So we did not only catalyze, we created an explosion of semiconductor. Thank you, everybody.
Yeah, I think you thanked everybody, but I think you played an important role, Satya. Hey, Satya, I think congratulations. I think you played an important role in the whole thing, spending so much of time. Because we started calling him, he's probably enrolled by MIT as a full-time employee.
I would now request all the team members from organizing team to kindly come up on the stage and let's capture this moment. Until next edition of Semicon India.
All set to welcome the Honorable Minister of State and also importantly the Chairman of the Steering Committee. Ladies and gentlemen, put your hands together and welcome Shri Rajiv Johnson.
Namaskara and good afternoon. On that beautiful note, I think it is time to draw the curtain on what has been 3 days of very inspiring, very energetic, and very illuminating conversations about our mission to catalyze India's semiconductor ecosystem. I will not speak for too long. It's been 3 days and I'm sure that most of you who have traveled from far have to get back. Tomorrow is a Monday. I'll just quickly say a few points. One of the best ways to characterize a success or failure of a conference is the intensity or the interest or the freshness of each day. And Vindham, I think he's not here anymore, he was telling me that he has never attended a 3-day conference like this where every day he was looking forward to every session. And I think that is in itself a testimony to the quality of this Semicon India 2022, the inaugural Semicon India 2022. And let me start by just thanking each and every member of the steering committee, my colleagues in the ministry, and indeed every one of the industry stakeholders who worked very hard to make this inaugural Semicon India a success. Again, let me just quote, 2 young engineers walked up to me at the end of day 1 as we were moving to dinner, and they said to me that this, according to them, actually it was the second day, yesterday, and they said to me that this is the best collection of high-tech leaders that they have ever been part of. So I think that is again a testimony to the very high quality of conversations around compute, around AI, semiconductors, the future of systems, systems architecture, talent, fab, that characterize these 3 days. The MOUs you also have heard of and read about. Those MOUs also summarize many of the leading foundational elements of this conference on manufacturing, talent, design and manufacturing, and partnerships. I can assure you that on behalf of our Honorable Prime Minister and the government, and he made that very inspiring speech on day one, and he set the bar for all of us in government, which is that the government is an AND gate and not a NOT gate. I can assure you that we will play the role of an AND gate for this ecosystem. Our mission is our Honorable Prime Minister's vision. We are very, very determined as a team, as a nation, as a people, to ensure that his vision of making India a player, a significant player in the global supply chains for semiconductor is actualized and realized in the coming months and years. I will say what I said in yesterday's press conference to end this whole 3-day Semicon India conference. It used to be that the world used to say, my system is powered by AMD, my system is powered by Intel, my system is powered by NXP, my system is powered by TI, Infineon, NVIDIA, as the case may be. And Microtech, I noticed Microtech is there. But what I think the vision now for us, the mission for all of us is that regardless of which platform, regardless of which brand, which company, regardless of whether it's a global company or an Indian startup, whether it is a DIR5 product or an ARM product or an x86 ISA, that we should be in the coming years be able to say that my system is being powered by India inside. And I think that is the goal. That is a thought I will leave you. That is a thought I want to leave in all of your minds, that our mission is to make sure that India is inside all of our future systems. Thank you all again for participating, for engaging, for conversing, and contributing today, and I hope you will continue to do this in realizing and actualizing our Honorable Prime Minister's vision and India's vision to make India's ecosystem, semiconductor ecosystem, a significant partner to the global supply chains. Thank you. Jai Hind.